Hello. Today we're going to look at the relearning for conditionals. Uh, First off, John realizes that he can prove that the sum of an interior angles of a triangle add up to 180 degrees. Is this an axiom, a definition, or a theorem? Well, the main thing you look for here is can he prove it? And yes, he can. Since he can prove it, we know that this has to be a theorem. And your reasoning is because he can prove the statement. Now, axioms we accept to be true, and our definitions are meanings built off of other things. So theorem is the only thing that makes sense here. Right here, we have a statement, if an object is a rose, then it's a flower. Well, let's write in red. Seems like a good idea to write in red. So here we would say if an object is a flower, then it is a rose. So we're just flipping the order in the converse. In the inverse, we negate the hypothesis and the conclusion. So I'd say if uh, if an object is not a rose, then it is not a flower. And then finally, we want to do the contrapositive. It's if not the conclusion, then not the hypothesis. So if it is not a flower, then it is not a rose. So if we take a look at this and see, let's try to assess truths. If something's a rose, does it have to be a flower? Yes, anything that's a rose is a flower. If an object is a flower, then does it have to be a rose? No, this one's false. If it's not a rose, then it's not a flower. No, that's not true because you can have like an iris. That's not a rose, but it is a flower. If it's not a flower, then it's not a rose. If it's not a flower, then it can't be a rose, unless you have a person who's named Rose, but I guess then that would be a capital R. But it's missing the point. All right. Here we have biconditionals. Biconditionals are statements that have if and only if in them. And a biconditional means two things. It means first the conditional. So I'd say if I brush my teeth, then I finished eating my breakfast. Now, the converse of that is when it's flipped around. If I finished eating breakfast, then I brushed my teeth. So this one statement using the if and only if means two statements, the conditional and its converse. All right, so now we're going to determine the validity of each statement and provide a counterexample. If an animal is a bird, then it's an eagle. That's not true, because an animal could be a hawk. That would be a counterexample, something that proves it false. If an angle has a measure of 100 degrees, then it's obtuse. That's always true. That has to happen. Now it says, draw an instance and a counterexample for the following statement. If angle ABC is 20, then FBC is 160. So an instance would be if I have A, B, let's have C out here, and I'd mark that this is 20 degrees. So then FBC has to be 160 degrees. And I'll throw a little f over here. Now, this makes sense because they both add up to 180. Now, a counterexample would be something that proves that wrong. So I could have these things where I have ABC. Now ABC still has to be 20 because this first part has to be true. So that's 20 degrees. And now this can be anything other than 160. So say this is 30 degrees. Now this would be a counterexample because the first part's true, but the second part is false. Give a counterexample and an instance to the following example. If an animal is a reptile, then it's an alligator. So a counterexample would be any other lizard, like a gecko. But an instance would only be an alligator. Draw a counterexample and an instance to the following statements. If ABC is acute, then all signs are equal. The counterexample is to draw an acute angle where these are all the sides aren't equal. This side is shorter. So we know that statement's false. But our instance would be drawing a time when this is true. So you draw a triangle and make the sides as equal as possible. And to note it, you can just say this side's equal to this side, which is equal to this side. Lastly, draw a counterexample and an instance of the following statement. If AC is equal to AB, then A is the midpoint. Now, if we have A, or we'd have to have B and C, and A would have to be somewhere in the middle. So AC and AB have to be equal. Now, if it's here, it's going to be exactly equal. But a counterexample would be if A is up here, and these two are equal. Because this is true, but it's not the AB is equal to AC, but A is not the midpoint. Now over here, we could do it where we have an instance where we make it true, where we have C, A, and B. And then we'll say this is true because these two sides are congruent. So that means it has to be the midpoint. Finally, draw a counterexample to the statement. If AM is a segment in ABC that connects A to the midpoint of BC, then AM and is perpendicular to BC. This one's a little tougher. So we have triangle ABC. If we go from A, B, and C, if we go from A to M, and it goes to the midpoint, does that looks like it's in the middle, but it doesn't look like it crosses at 90 degrees. So that means this would be a counterexample. Now, if I wanted to make it an instance, I would have to draw a time where it hits in the middle and it crosses at 90 degrees. So that would be A, B, C, and then M. So we'd know that this crosses at 90 degrees and these sides are congruent. All right, that's enough for the video.